fuel cells to really be a game changer in the wastewater industry of the future, since they simultaneously treat wastewater and produce electricity. Now, this game-changing technology probably won't be changing the game for at least a couple of decades. But people are making great strides on the technology, particularly when they're looking to treat high-strength organic wastes. But in this project, one of the things that made this project so unique is the fact that it was performed on dilute wastewater from a wastewater treatment plant, not on a synthetic wastewater, which we've seen in some other projects in the country. And also it was performed at pilot scale as opposed to bench scale. So there were 4 of these reactors. They were 16 liters each, and they were operated for a period of 6 months. They were a novel multiple anode cathode granular activated carbon configuration, and ultimately the system achieved COD removal of about 80%. And additionally, as part of this project, a new catalyst was developed and tested, manganese dioxide catalyst, and that catalyst was found to achieve similar power generation compared to the platinum catalysts that are used in most microbial fuel cells today. But the platinum catalysts, as you would imagine, are much more costly than these manganese oxide catalysts. And this report was issued in 2011 and is available online. Now I'm giving you the 30,000-foot view of all of these projects, so if you're interested in more information, please check out these reports or feel free to contact me and we can talk about them. Okay. The next collaborative project is one that stems from a market characterization that NYSERDA had performed in 2008. We were ramping up in support of our anaerobic digester gas to electricity program. That's part of New York State's renewable portfolio standard. There's the main tier that has those very large wind farms and photovoltaic systems, but there also is something called a customer-sided tier for smaller projects where electricity is generated behind the customer's meter. So this market characterization was performed for the municipal wastewater sector. We also did one for the high-strength organic sector, which I won't talk about here. And the characterization confirmed our assumption that significant barriers exist to these projects. In fact, in New York State, less than 20% of the larger plants are found to generate and or use biogas, be it for CHP, combined heat and power, for heat, for direct drive equipment, for any number of things. And this is similar to what's been found throughout the country. So in 2011, WRF and NYSERDA decided to co-fund a study that was based on pinpointing the barriers faced by utilities when implementing both anaerobic digestion projects, but then projects that would use that biogas. And the first phase of the study was an online survey. There were 200 respondents nationwide. The second phase was a series of focus groups attended by utility managers and staff. We were really looking to get information from people who are working on these systems, hands-on, not necessarily consulting firms that serve them. And four of these focus groups were held throughout the country, including one in New York City. And the New York City focus group was attended by several of the New York City DEP, I'll call them decision makers. And many of the findings of this project were not surprising. You know, it's very clear that economic barriers are dominant. The perception of inadequate paybacks and lack of available capital, but there were a few surprising outcomes from this project. For example, we noticed that many of the respondents that were answering the survey from the very smallest utilities, those 1, 2, and 3 million gallons a day, had found the means to justify biogas projects at their facility. And if you've seen the EPA Combined Heat and Power CHPP report that was most recently issued this last fall, I believe they typically say the rule of thumb is, unless your project of 5 million gallons or more, don't even contemplate anaerobic digester gas, particularly if you're going to reuse the biogas or use the biogas. But out of this report, we found that that's not necessarily true. Now, in contrast, there were also a number of respondents from larger facilities in the 10 to 25 million gallon per day range who identified inadequate biogas production as a barrier to them taking on one of these projects. So we found that was pretty interesting. And the draft final report is currently under review, and again, of course, it will be available through our website. Now, I'm going to talk a little bit more about this project, the Barriers Project, because it actually led to a couple of other efforts that are ongoing in the U.S. that I want to talk about. And one of those is an effort by WEF, the Water Environment Federation, to collect data on current and potential production of biogas at municipal anaerobic digestion facilities in the U.S. Many of us, I think, rely on the Clean Water Needs Survey to provide us with a picture of actually what's going on in the country. But if you start digging into that survey, you'll find that much of that data is either incomplete or completely inaccurate. I think I was looking at New York State plants, and there are a number of incorrect entries among New York State plants in that document. So this effort is being headed up by NEVRA, the Northeast Biosolids and Residual Association. It includes the American Biogas Council, which is a relatively new biogas-related lobbying entity that I recommend checking out if you're not aware of them. There are also several consulting firms that are a part of this effort, as well as the Massachusetts DEP, the EPA, and NYSERDA. And the first phase of this project should be completed by early 2012. The Barrier to Biogas project also led to a collaborative effort with the US EPA. We are currently working with them on something called the Environmental and Energy Opportunities from Biodigesters and Biogas Technology Market Summit. This summit is being held next month, May 14th, at American University, and it's focusing primarily on the key economic issues that are impeding increased use of digesters. Things such as, we all know natural gas is at a historically low price right now. And we're finding, particularly when we're working with the dairy industry, that is starting to impede some of those projects. When you can get really cheap gas, people aren't necessarily as apt to look to you for biogas to produce electricity. We will also be looking at REC price impacts. In New York State, there's no mechanism for truly tracking RECs from biogas projects, and many folks, myself included, think that is a real barrier to getting more of these projects funded and built. We'll also be looking at the availability of supplemental feedstocks. As you know, supplemental feedstocks can greatly increase biogas production at both wastewater plants and dairy plants. And then we'll be talking a bit about digester byproducts. and identifying the markets for those byproducts. And Kartik can talk a lot about what those byproducts are. Our third and the last WRF collaboration I'm going to talk about is an effort that's focusing on energy self-sufficiency at wastewater treatment plants. WRF did a famous case study in the last year or so, maybe 2 years, about the Strauss plant, which is a plant that essentially, at this point, is probably making more electricity than they're using to treat the wastewater that comes into the site. Kartik and I were at a meeting a couple of weeks ago, and there were a number of other individuals, these were from the US, who are doing similar things. The folks out at East Bay MUD, the East Bay Municipal Utilities District. We have a couple plants here in New York, Gloversville, Johnstown, Joint Wastewater Treatment Facility. Very soon we'll have another in the Albany area. So recognizing that it is possible for these wastewater treatment plants to be energy self-sufficient, this RFP was issued so we can pull together that information so that other plants who are interested in achieving energy self-sufficiency, or at least moving towards energy self-sufficiency, can do so. And proposals were due for that RFP on February 27th of this year. A team has not yet been selected, so more will come on this project in the future. And in the vein of energy self-sufficiency, I also want to mention a WEF initiative. WEF is working on a roadmap to develop a roadmap for achieving energy neutrality at wastewater treatment plants. Several of us met a couple of weeks ago at a workshop, Kartik and Steve, to help get this process moving. And the goal is really to not so much serve as a guidance document, but to identify opportunities for integrating all of the really good existing tools out there into a place that folks who don't know where to start or who have only marginally begun can turn to and ultimately at least improve their energy balance. And it's anticipated that a high-level version of the roadmap will be presented at WEFTEC 2012, which is, I believe, October. Okay. Now, before discussing our ongoing water RF collaborations, I want to mention one from the recent past. NYSERDA has been a strong proponent of understanding the energy implications of UV disinfection technologies, and also for developing mechanisms to optimize these systems. And as such, what you'll see at the top, we provided seed funding for something called the UV Validation and Research Center of New York State. It just so happens to be located at a wastewater treatment plant that had a lot of excess capacity. And that facility was also supported by the New York City DEP and about 8 of the major UV technology manufacturers throughout really the world. And this is the largest of only 4 such facilities in the world. There are 2 in the US. And it has been in operation since June of 2003. And the facility was used by the DEP to validate their reactors, to actually select reactors for their UV disinfection facility. Over there on that large reactor stand, I think is where they did the majority of their testing. And then here on the left is another one of those reports that can be found on our website. This is a project that was done with Carollo engineers at the City of Troy drinking water treatment plant. Out of this project came an Excel-based tool that you can use to look at a number of operating protocols for your UV disinfection system when you're in the design phase of a project. It'll also allow you to look at the effects of lamp failure on meeting various regulatory requirements. And then on the right, you'll see a slide that talks a bit about another project that was actually validated at the UV validation facility. It was a technology developed by Purdue, dyed microsphere actinometry. Dyed microspheres are these very small particles. The size and density mimics a microorganism, like a cryptosporidian microorganism, and the trajectory of the microsphere through a reactor is similar to that of a microorganism. And what happens is you link a UV-sensitive dye to the microsphere, and that dye, which is non-fluorescent at the time, and when that dye is exposed to UV, it becomes fluorescent. And after the water passes through the reactor, you collect a sample, and that sample then is sent through a flow cytometer, and the fluorescence intensity of the sample can be correlated to UV dose. So New York City DEP actually selected to use this technology to help optimize their system, which should result in significant savings in operating costs while the system remains in compliance with the UV Design Guidance Manual, which is essentially the Bible for designing UV disinfection systems. Okay. Now I'm going to talk briefly about the Water Foundation, Research Foundation project, and then just say one thing because I'm in New York City, and it's not related to either of the research foundations, but it's relevant, and then I'll wrap up my talk. So right now we have 4 ongoing collaborations with the Water RF. This one I'll talk about in a moment. One is the development of a toolbox for utility energy greenhouse gas emissions. So this is a series, all these 4 projects really have a lot to do with looking at carbon emissions from, and other greenhouse gas emissions from water and wastewater utilities. And there's also, of course, energy is a strong component of that, so they also have a heavy energy focus. So in this toolbox, the rationale behind funding this work is that we realize that water utilities face fundamentally 3 different situations with respect to energy use and greenhouse gas reporting requirements. For example, in the UK, there are clearly mandated regulatory reporting requirements. But in the US, those requirements are much less certain. And typically there's some combination of federal, state, and voluntary requirements. And finally, in places like South Africa and Singapore, there are no real prescribed regulatory reporting requirements, but there is pressure to monitor energy use and greenhouse gas emissions. So in the project stems from our desire to address sort of these second and third situations where reporting requirements are unclear. And so what we're doing in this project is identifying the common tools used across water agencies to measure and track energy and greenhouse gas emissions. And we're doing this in the US, in Europe, South Africa, and Southeast Asia. We're looking at the underlying algorithms and models that support these tools and identifying where research is needed to improve their accuracy and specificity. And finally, the goal is to have some sort of a harmonized best set of practices that can be used across utilities and geographic regions. And the draft final report has been submitted and it is currently under review. Our second project with the Water RF is on changing mindsets to promote the design of sustainable water infrastructure under climate change. We're not all like New York City. And we know that most water utilities are very conservative organizations, and we're happy they are because they provide us with high quality drinking water, which means we remain healthy. However, achieving sustainable utility operations is likely going to take some change of mindset, and typically people are very leery of undertaking enterprise-wide transformation. And so the goal of this project, the Changing Mindsets project, is looking at the early adopters, folks like New York City and other early adopters in the country, to help develop guidance for other utilities on how really they can change their municipal culture to embrace and support ongoing programs that support sustainable water operations. And this report is also in a draft final form and under review. Okay. This project, Energy Efficiency Best Practices for North America Drinking Water Utilities, is complete. The document is available through NYSERDA's website. It's a written compilation of best practices and 16 case studies. 5 of those case studies were from New York State utilities. This report also includes an Excel-based searchable database of energy efficiency best practices. Okay. And then on to the last Water RF project. We are working with the Water RF to co-fund a project titled Vulnerability Assessment and Risk Management Tool for Climate Change to assess potential impacts and identify adaptation options. So case studies are being developed as part of this project to understand climate risks to water utilities, and then a risk assessment and management framework will be developed based on robust decision-making methods and probabilistic assessment. And this framework, we're working with New York City DEP to pilot this, this framework. We will also work with the Colorado Springs utility to pilot this framework. And the data analysis portion of the New York City pilot project should be wrapped up in June of this year. Okay, so before I conclude, I want to mention a program that NYSERDA has since we're in New York City. And this program is our Downstate Regional Digester Gas Program. So we had a program, the Anaerobic Digester Gas Electricity Program, that was available to wastewater treatment plants and other entities throughout the state. It had a cap of about $1 million. And we heard from individuals downstate that $1 million is not enough money for us to consider undertaking a project with you. So the cap on this program is $3 million. And this program is a little bit different than our other program where we're just incentivizing electricity produced by these behind-the-meter biogas systems. So this program incentivizes renewable biogas-fueled electric generation projects in ISO zones G, H, I, and J. So you'll see that the city and those areas just north of the city in the lower Hudson Valley. And renewable biogas is biogas that comes from feedstocks that include manure, agricultural residues, high BOD, industrial organic wastes such as food and beverage wastes, and municipal wastewater treatment sludge. Landfill gas is not an eligible renewable biogas in this program. The renewable, now here's what's different with our other program. The renewable biogas can either be locally fed to the generator, which means that if you're at a wastewater treatment plant that has a digester, you can have an engine generator or whatever prime mover you decide to have there that's generating electricity, as long as the system is interconnected to the grid. But what's different about this program is you can also contract for delivery through utilities natural gas pipeline, and this is referred to as a pipeline-directed biogas project. So, for instance, you can, a wastewater treatment plant can develop some sort of a contract with, say, a hospital. You know, we agreed to put this much renewable biogas in the pipeline. The hospital says we agree to take this much renewable biogas out of the pipeline and generate electricity with that biogas. And the incentive then is paid on that electric generation, but of course there would be some sort of a relationship between the gas supplier and taker, so that the gas supplier also was being provided some of the incentive. Okay, so finally, where is my program going and where would I like to go? Well, I'd certainly like to continue to support these collaborations with WRF and the Water RF. And I certainly hope some of that is done with projects that you are submitting via proposal, and you ask me to be a part of the team, and I'm able to get you some co-funding, and then it's competitively selected. I also am looking to really improve the outreach, my outreach. There's a lot of great information that's developed